collaborative engineering is becoming a huge trend in the industry.
The importance is to bring people together. Open source's great strength is that engineers talk to engineers without constraints.
We have to motivate and invest together. By nurturing the ecosystem and partners within those systems, I believe that we will benefit.
We've got people from industry, people from academia, we've got entrepreneurs, but they all are sharing this vision of collaborating in hardware and software and systems, and there's a lot of excitement. It's like the perfect opportunity to really come and see what's going on.
We can share ideas, we can learn new ideas, we bring all our expertise into this system. This is an opportunity through our membership of the Open Hardware Group to meet a whole new community.
The Open Hardware is one of the different organizations where they see the values of collecting the people from around the world. Producing the real results can be beneficial for the whole economy.
Excitement's growing. I think it's really the right time to really get involved.
So this is the 9:15 talk where I'll present the open source processor IP development that we have underway within the Open Hardware Group for use in high volume production SoCs. Okay, so from an outline perspective for my talk, I'm going to talk a little bit initially about the challenges of SoC design using open source IP. And then in particular, we'll introduce the Open Hardware Group and how we're structured and how we're trying to address those challenges, and provide an overview of the task groups and the cores, which we'll get into in a lot more depth over the course of the day. So from an SoC development standpoint, cost drivers are really all about the software associated with the SoC, the RTL design itself, and the verification of that RTL. And then, clearly the physical design and implementation of that design. And that accounts for more than 90% of the overall cost. And that makes sense for highly differentiated IP in the SoC. That kind of investment is probably warranted just from a business case standpoint. But for general purpose cores that, everyone has the same core, right, in an MCU kind of thing, then an effective open source model where the community is sharing effectively, like our software colleagues have been for the past couple of decades in terms of open source software models being proven and commercialized and monetized. Clearly, if we could organize ourselves to drive these costs down and share some of these resources as an industry, we'd be better off. But let's take a look at the barriers that have been stopping the industry from adopting an open source hardware IP model. Probably the first and most obvious one is the quality of that IP, right? If you're an SoC designer or an IP designer inside a large SoC company, are you going to walk into your boss's office and get your badge, throw your badge down on the desk and say, okay, we're just going to download this core from a university repo because it's cool and I saw it here on GitHub and we'll put it into our next high volume SoC. There's lots of challenges associated with that. How well is it verified? From an ecosystem standpoint, what's the roadmap look like? Are there IDEs to support it? What operating systems have been ported to the core? Tool chain? How are we doing on PPA metrics? And then overall, from a licensing standpoint, how is it licensed? Most semiconductor companies have a very deep treasure chest of IP patents and a deep portfolio. They certainly want to understand how or if that portfolio is going to be exposed or risked in any way. So permissive use licensing is a must-have. So one of the interesting things that's happened, and some of you may know, I started the RISC-V Foundation back in 2015, together with the team from UC Berkeley and a bunch of industry sponsors at the time. And really, the RISC-V ISA has ushered in a whole new frontier of processor design and innovation. And without that, we really wouldn't be talking about open source cores to the degree that we. So that's the good news. The barrier to innovation around processor design has dropped dramatically as a result of the existence of the RISC-V ISA. But on the flip side of that, how many open source cores does the industry really need? They're certainly great from a pedagogical, overall teaching and academic perspective. But just because we can create new cores every couple of days, if you will, for a new team decides, hey, I'm going to put a core together and throw it up on GitHub, and there's my open source core. Widespread industry adoption of these artifacts is what's going to drive acceptance and commercialization of the open source IP. So you can make an argument that too many cores is actually a problem. How do we establish critical mass around a family or a handful of cores that the bulk of the industry can get behind and support and create a sufficient adoption that these cores will be maintained and have a sustainable future? And that's exactly what we're trying to do within the Open Hardware Group. So to illustrate the problem a little bit, this is a table that's actually out of date, but it's illustrative nonetheless, in that these are the open source RISC-V cores that were available as of sort of the turn of this year, so early January, last December, early January kind of timeframe. And the point is, there's lots. And like I said, academically, this is interesting, but industry adoption-wise, this is too many. So what we've worked on in Open Hardware Group is we've had a very good relationship with the team at ETH Zurich in Switzerland under Professor Luca Benini, where they developed under their Pulp platform cores called the RISC-V core and Ariane. And those are the seeds, if you will, or the catalyst behind the creation of the Open Hardware Group to begin with. So what is the Open Hardware Group? We're a nonprofit global organization, federally registered in Canada, and with an international global footprint, specifically to curate an environment where hardware and software developers can collaborate on open source cores and related IP and software in support of that IP. And the first few projects are around a family of open source RISC-V cores called the Core 5 family. So we have developers in North America, Europe, and Asia. And really what this is a virtual team, if you will, where we combine the contributors from various member companies into these virtual teams to host and curate the highest quality IP that we can, open source IP that we can, in line with industry best practices. So we're a system Verilog based ecosystem. We adopt and use commercial tools from the commercial CAD industry. We're not trying to create open source everything. We're literally trying to curate and verify and supply open source cores based on RISC-V as our initial projects. We have very, very strong support from industry, academia, as well as individual contributors, with over 53 members and partners worldwide. So here's the industry ecosystem within the group. And many large companies, small companies, software companies, hardware companies, systems companies, making up quite a breadth of coverage in terms of stakeholders in the industry. Our research ecosystem is strong and is continuing to grow. We'll be adding a number of universities to this program in the coming months. And in fact, my slides, when I put together these membership slides, they're generally always out of date. And in fact, overnight last night, I got another signed membership agreement bringing us to 54 members. And then on the partner ecosystem standpoint, these are our partners that we're working closely with to help bring these open source artifacts to the ecosystem. So we're very well supported, and a little over a year since we started the organization, we're pretty pleased with the growth that we've had in the industry. have a strong board of directors chaired by Rob Oshana from NXP. Quite an international footprint with both academic institutions such as the Barcelona Supercomputing Center, silicon companies, and systems companies, providing a broad representation at the board to help us steer the direction of the organization. And then underneath the board, we have two main working groups, the technical working group and the marketing working group, which, if you think about this as a typical commercial company, the technical working group represents effectively the R&D, our engineering organization within the company, and the marketing working group represents traditional outbound marketing activities to grow the ecosystem. And within the technical working group, we have 4 task groups. The cores task group looks after the Core 5 family of cores. The verification task group verifies those cores. The software task group, and you'll hear from members of the software task group this afternoon, works on the tool chain and IDE work and operating system support. And then the hardware task group, and you'll hear from folks from the hardware task group as well, looks after chip level implementations, whether they be in FPGA or hardened SoCs, as well as board level implementations of the cores. So just quickly, the technical working groups chaired by Sebastian Ahmed from Silicon Labs and Jerry Zhang from NXP. And as I said earlier, this is effectively the R&D of the Open Hardware Group. And we're partnered very closely with the Eclipse Foundation, not just because of the good IDE tools and software work that they do, but also because of their proven Eclipse development process. And we leverage and implement the Eclipse development process as our engineering release methodology for how we intake contributions, validate those contributions from an IP standpoint, and then release them for use in the ecosystem. So the cores task group, and we'll get into more details of these cores in a moment, but the cores task group is chaired by Arjan Bink from Silicon Labs, and the vice chair is Jérôme Gavrenin from Thales. And we effectively have become the committer or owner now, if you will, of the original RISC-V core and Ariane core, which we call the CVE4, an embedded class 4-stage core that implements the 32-bit instructions extensions, IMFC, and XPulp, some custom extensions from the Pulp platform. And these cores came to us from, as I said earlier, the team from ETH Zurich under Professor Luca Benini's leadership. And as you'll hear later in the talk today, Florian Zaruba and Davide Schiavone are both PhD candidates under Luca's leadership, and are also starting their industrial careers, if you will, as employees, as directors of engineering with the Open Hardware Group. So we're thrilled to have both of those gentlemen as part of our staff. The Ariane is, which we call the CVA6, is a 6-stage in-order core implementing RV64GC. And it's implemented to be a full application class processor capable of booting and running Linux. So one of the biggest impediments to adopting open source cores, as I said earlier, is the quality of the IP, or just open source IP in general, whether it's cores or not. It's just the quality of that IP. And is it verified to industry level standards? So that has been a big focus of the early activity within Open Hardware Group, putting together a verification test bench that is as good as, or certainly quite similar to, what a typical SoC company would have internal in their organization if they were doing this work on their own. So this slide is a little busy, but it illustrates what we've built around the Core 5 verification test bench. So it's a System Verilog UVM environment. We leverage the Google Random Instruction Generator to generate test programs with random instructions. We also have manually written test programs that can be fed into the simulation environment. And the tool chain is invoked by a UVM run flow. We run the GCC compilers to generate the machine code, gets loaded into the instruction memory, and we have a series of memory wrap peripherals as part of that memory model that feed the core. And all of that is compared against the Imperis UVM RISC-V reference model. And the same instructions, the same test stimulus runs on the reference model and the Core 5 DUT, be it the CVE4 and soon to be CVA6, with a step and compare functionality that compares the program counters and status registers against expected results at the retire of every instruction. So this is a pretty sophisticated UVM test environment and is really what increases the confidence that our SoC member companies have in being able to use this type of IP. The software task group, which you will hear more about some of the work later today from the Embecosm team, is chaired by Jeremy Bennett at Embecosm and Yunghai Shang at Alibaba. And again, this task group is an important task group for us and is responsible for developing and supporting a software tool chain, operating systems, IDEs for the cores and IP that we develop within the Open Hardware Group. And most importantly, as with our the actual core RTL work, we expect these cores will be adopted in commercial SoC chips that are sold by various members of the ecosystem. We also expect that our software work will be upstreamed into the main repos of the various tool chains that we're working into and supported commercially by the ecosystem. Commercial adoption of open source artifacts is what keeps these open source artifacts active and maintained and supported in the industry. So it's a very important aspect of the work that we're doing in the software task group, as it is with any of the hardware work that we're doing. So the hardware task group, and you'll get to hear from both of these gentlemen today, is chaired by Hugh Pollitt-Smith from CMC Microsystems, and the vice chair is Tim Sachs from QuickLogic. And the hardware task group is basically responsible for taking any of the IP that we have been developing in the cores task group and implementing that IP into either FPGA or hardened SoC implementations at the chip level. And then for the hardened SoCs, developing development kits and eval boards for those SoCs. So today we'll be focusing on the Nexus platform, FPGA platform from Digilent, and the FPGA-based Core 5 MCU. We'll also have a talk from QuickLogic on the production MCU SoC, the Core 5 MCU that we'll be building in 22 nanometer FDX with Global Foundries. So with that, what's next? As I said earlier, overnight, we had another member join, so we're now at 54, not 53, and we expect the ecosystem to continue to grow. We'll probably be over 60 by the end of the year. Heading into 2020, we had a target of being at 40 by the end of the year, and we eclipsed that in May, and we'll be at 60 by the end of 2020. We'll probably also have new cores that are either added to or soon to be added to the family, the Core 5 family. The CV32A6 is actually already underway. This is a 32-bit parameterized version of the 64A6, so the Ariane core, which was originally developed as a 64-bit core. The team at Thales has contributed a parameterized option in the code base to produce either a 64-bit core or a 32-bit core, and that's all from the same code base through parameter selection. And there'll be more cores added to the family. So as with any IP roadmap, if you will. We will have a roadmap of system Verilog-based RISC-V cores in the Core 5 family that cover the waterfront of performance and extensions of the RISC-V ISA. We'll also have some work around on-chip SoC interconnect in terms of standard fabric and buses. These are predictions, by the way. This is not a guarantee, but we expect that that'll be the case, and we'll be having heterogeneous support, cluster support, leveraging embedded FPGA work. And you'll see as part of the Core 5 MCU SoC that were built at 22FDX, you'll see some of that foreshadowing with the project proposal that the QuickLogic guys will present. So with that, just about 10 minutes left in the talk as we get to the summary slide. We're pretty encouraged with the progress that we have for with the Open Hardware Group and the growth of the ecosystem. The ecosystem is only as strong as the participating developers, both from member companies and individual developers. So, we encourage you to join us. Go to openhardwaregroup.org for membership info. You can follow us on their social platforms as well, on Twitter and on LinkedIn. If you just Google Open Hardware Group, the first 10 or 20 links or so will be obviously directly to us. So you should be able to find us easily. Hopefully, what we're going to present here today, together with our co-hosts from CMC and Eclipse, will encourage you to start participating in this vibrant ecosystem. And with that, I can turn to the swap card platform and see what kind of questions maybe have come in from the group. Okay, so one question that's come in to me is regarding membership and participation and use of the IP. Do I have to be a member to participate and use the IP that is being curated by this ecosystem? So I'll address the use part. This is purely open source IP. Anyone can go to the GitHub repos that we have for the projects and download any of the IP, use it as they wish. The trademarks, to use the trademarks, you need to be a member, but nonetheless, if you just want to use the IP, put it in a core, put the core in an SoC, and take it as is. Reuse the verification infrastructure. Maybe you're designing your own core and you want to just use our verification infrastructure, and you can do all of those things. And no membership is required. It's truly open source IP. The reason you want to be a member is the task groups that I referenced earlier are the governing bodies, if you will, that decide what we work on and what the priorities are and what features and functionality will go into the cores, what the test strategy is, what we're going to develop from a tool chain standpoint on the software side, what we're going to build with our silicon and board partners for reference designs, both at the SoC level and at the board level. So that membership gives you the opportunity to participate in those discussions and help steer the direction of what we're working on. And that's why these companies are joining. If you have an interest in using the IP and in fact are trying to develop a commercial offering around the IP, which we absolutely encourage, then I think you'd be motivated to participate and help steer the direction of how this IP takes shape. So that's why you would participate. We have another question that's come in regarding membership that I can take. Do we have community or only corporate membership? So anyone can participate. Membership is corporate driven. Nonetheless, individual contributors, all they need is an Eclipse account. Well, everyone needs an Eclipse account. I'll talk about how we curate the IP and how we manage through the Eclipse development process and ensure the quality of the IP that we curate. So the way that we manage it is through the Eclipse development process, all contributors have to register with an Eclipse account, sign the Eclipse contributor agreement electronically, and they associate their GitHub ID with that account, with their Eclipse account, and then every contribution that is made to our repos under that GitHub ID is then authenticated as a contributor. So an individual can participate simply by registering for an Eclipse Foundation account, making sure that they enter their GitHub ID as part of their Eclipse account. And then as that contributor issues a pull request or any contribution to any of the Open Hardware Group repos, their user ID is authenticated against that Eclipse account as having signed off the Eclipse contributor agreement and is part of our IP validation and release process automatically. So you can participate as an employee within your company, and we encourage that because commercial support for the open source efforts is needed in order for us to sustain an ecosystem. But individual contributors from wherever they are outside of their company can participate by simply signing up with an Eclipse contributor agreement and an Eclipse account. And all of that's on our website as well.
It's guaranteed that I die legend. Yeah, son God, homie, I'm reverend. Preach, just protecting my investment. Ask about me, integrity's not in question. Straight up, all the way up with the same ones that was down from the jump. Day one, same ones been around when there ain't funds. Even got love for fake ones that changed up like they break ones.
Let's go now.